Hello guys, Alias Theory Builder lesson. In this one I will tell you about the cross-align method that's designed to maintain a proper acceleration, a good flow, and an active history between aligned surfaces. Now, as you may know, you can align one surface to another, but you can't align both of them to each other at the same time. As a result, surface you align to will always be a driver, which means its parameterization can't be changed by the align tool. Thus, aligned surface takes not only a really heavy load to maintain the curvature, but deforms more than you desire in the process, and the cross-align method designed to battle that. Okay, before we start, I need to mention that we have a tool that's supposed to do exactly what cross-align method does. It calls Align 08. It can align both of the surfaces across the joint, but it is difficult to control and it is limiting your options. So it works decent only on symmetrical examples. And it's called 08 because it is from 2008, was deprecated and replaced by the current align tool that, well, unfortunately doesn't have that option. So let me show you how cross-align works. I will show you two examples, just a basic one for you to understand the concept, and a more complex one that, let's say, illustrates a practical usage. So let's start with the basic. Let me open up the layer. Okay. So what you see here is two surfaces. So this is the surface one, and this is the second one. Now what I will do is I will extend one of them a little bit further. So use extend tool. This one, just like that. Okay, so now we have three surfaces, first, second, and third. So what I will do is I will align this surface to the newly created one, this one. Now this surface is a technical surface, basically a bridge between the two. So I'll align it here with the, I will be working with the curvature continuity, so I'll align it to G2, to the edge, and with position influence set to 1. On top of that, the edge is supposed to be not skew, but the edge align, like that. Now what I will do is I will align this surface, let me just pick it, this one, to this one. And I will use the same parameters as with the first one. So what is happening is that this surface aligned to this one, and this one to this one. They both aligned as a curvature. Now, obviously, this is just a two straight planes, so let me show you what will happen now. So if I will use the CVs of this newly created surface, this one, which is a technical surface, or basically the controlled surface, I can operate with that. And by moving each CV, so as you can see, I have two rows of CVs, the three rows, the position, the tangency, and the curvature. So if I want to change the way how these two surfaces connected across the edge, I can, well, move accordingly the corresponding row of CVs or individual CVs. So right now, let me just start with the tangency actually. So what I'm gonna do is I can just move that, and what happens now immediately. Both of the surfaces changes to maintain the curvature. Remember, both of them have a curvature, and they both of them basically aligned here through this surface. That's why it's called cross-align. So I will pick it. I can just move it somewhere here. Now I can, for example, work on the second row of CVs to tweak it a little bit. Once again, I can do that. Of course, I can move the position as well. So if I will take the position, actually I will take all three. And for example, I can move them kind of up or down. For example, these ones up and these ones down. And let me just hide it temporarily. And you're gonna see what's happening. So these surfaces are connected as a curvature, basically between each other. They both have a history, and the trick here is we have these third surface, which actually used as a guide, as a control surface for both of them. Now it's actually very simple, right? And but it's a very powerful instrument. Like let me just kind of move these two. Let's just do it like this. So this is a very powerful instrument because I can do any changes and I will be absolutely sure that the flow will be natural at this edge. It's not like one surface have a heavy burden to carry all what the other surface have. No, it's basically shared between them, basically accordingly, creating a more natural transition. And these technique used very heavily in the industry for a lot of products now, for consumer electronics, right, left, and center. It used in automotive industry for what I know, and in general, it's like basically a bread and butter. It doesn't mean that you'll always use that. Sometimes it's, well, somewhat unnecessary, but there is a lot of situations where you can't. No, you can, but you will spend a lot of time fiddling with the CVs to create somewhat like the same result, which you can really easily assemble using just the additional surface, a control surface. Well, so yeah, you need to understand this is not like your magic wand, right? Like you can do everything with this. You don't need to, and you can use the standard CV massaging or CV manipulation and the align tool together to basically create the same results. But if you have a lot of surfaces, not 2, 3, 4, 10, imagine that you have some kind of complex shape, it will be problematic and you will spend a lot of time. And in most cases, you just don't have that time. Okay, so this is basically the general concept how this works. Let me just move it final time, like somewhere here. Here we go. So yeah, this is the way how it operates, and it will always operate until you basically just delete the history, right? And by the way, these railing surface which we created, we actually, if we have some kind of history to that as well, because you created from some surfaces, you can easily kill this. The kill history, it will not affect this connection anyway. Okay, so this is just the core, the meat of the cross align. Now let me show you the more practical usage of it, at least one of it. So let me just place it right there and open up the second example. All right, so I quickly assembled, like, it looks like a mouse actually, somewhat like a generic and very boring and lazy mouse. Now I will move CVs around, but basically it's just like, very simple construction. It's just the 4 curves and the rail between them with the slight CV manipulations here and there to create the desired surface, and just the regular 5-degree curves which basically have this transition curvature here and just the direction here. So and this one is just a 3-degree curve, nothing special. So what I want to do is I would like to fill this area, because right now it's empty. So the cross-align method here will be a perfect example, in my humble opinion. So let me show you how I will do it. And actually, I will show you 2 examples based on this one where I will use the cross-align, and another one where I will do not, and you will see the difference. So now what I will do is I will do 2 squares, one here and another one here, and then basically align them together to create the desired shape. Now let me start with let me think. Yeah, you know what? I will build the guide surface, or the technical surface, first. And for that, I actually need to separate my main surface, because this is just a single chunk. So what I will do is I will project, guys, once again, this is a theory builder lesson, it's not a modeling lesson, so you don't really need to try to replicate it if you don't need to. This is not the point of it. It's more like the approach rather than the actually pushing buttons. So let me project it here, and actually have a leftover, so I'll probably use it. So and another one somewhere, I don't know, maybe here, maybe here, it doesn't matter. So somewhere here. So I have three two curves and surfaces and basically three chunks. Now I need to split this surface. I will use the divide option, so I'll use the trim tool and I will click on divide like this. So now this is the same surface, basically 3 times, but just cut separately. This one cut like this one like this, and this one like this. So this is still the same surface, and I will use it temporarily. I will remove it later. So why I did that? Well, I did that because, well, of the 2 reasons. Well, first, I need to create a rail, and I don't want to confuse the alias. When you have a really long rails, alias can flip the handles, and you just struggle to move it the proper way. And the second one, well, the second one I will tell you in a bit. So for now, let's build the guide surface first. So I'll use a rail. It will be a 1 generation, this one, and 2 rails, this one and this one. So I will click, oops, 2 rails, I'm sorry, click here and here. Oh, it's still confused a little bit. Let me just kind of move it right there. Okay, and this one, kind of, I don't know, something like this, I don't know. It doesn't really matter where it is at this point because I didn't really build the main surface first. So let's do that. So I will use a square because there is 1, 2, 3, 4 edges. This is perfect for a square or the rail. So I will create a square like this. Now I will delete the history and I will use the align tool instead. And I will align it with the position influence set to 1. I will go to the edge like this. And I'll probably increase the amount. Yeah, I will go for extra zeros so that it will follow with the blend factor of 1, just linearly. Maybe a little bit smaller. No, 1 is fine. Okay. Now I'll click on this one and increase. I'll go to explicit control on this surface and increase it maybe to, I think it just 3 will not be enough. I will say 4. And this one, let me just actually check explicit control like that. So this connection is now curvature, but this is a temporary connection. Let me now go in here and maybe tweak this a little bit. Sorry. So as you can see, when it is under the history, it's pretty easy for me to tweak this, right? So I'm gonna do it like this, I believe. It's position, okay. Oh, kinda like this. All right. Now, as you remember from the previous lesson, from the previous example, I need another surface here, obviously, so it will be another square. This is the reason why I have these 2 chunks, because now I can actually save myself a lot of time and create a square here. This is actually a catch with this, but let me just build the square first, and then I will deviate a little bit and show you the nuances with this. So second one, let me just go to this one, and this one. Alright, so now we have a square. Now before we move further, I would like you to take a look at this square. Now I know this is not the part of this specific lesson about the cross-align, but you'll probably encounter the situations like that. Now if it will be the real product, and most importantly it will be the final model, basically the clean model, I will not do it like this, because we have these kind of skewing here, as you can see here. So I'll probably do like one surface, then another surface, and the third one, and then I will really accurately, very carefully align everything with a lot of care, and I will spend a lot of time on it. But this is a concept, it's just for learning, so I can just cut corners. Now the reason why I did that, and I know that it will be the decent result, It's because this line is not straight. So between these points, right, between these vectors, they are not straight. There is an angle, and this angle is smaller than 180 degrees, and it kind of like gives you an ability to actually use this method. If it will be a straight line, then the result will be bad. It will be unusable. And let me quickly show you what I mean. So imagine that I'm gonna have I don't know, a triangle, right, like this, and I will detach it somewhere here, and let me bring a little bit more degrees to this, like that. I'll push it up, and then I will create a square. All right, now we'll check the square in a minute. Now let me just duplicate this, put it away, just recreate it quickly. I'll use a rail tool. Oops, one generation, one rail, like that. And then I will project this. No, not divide, please. Trim. Okay, now if I will isolate everything and I will use the zebra stripes, I believe it's, let me just hide the grid. It's kind of visible what's happened. Now this surface is the proper surface, the way how it's supposed to be. And these one, as you can see, they have these kind of discrepancy, I would say, in the form. You see, it doesn't really behave the way it's supposed to, and that's because of these conversions. It basically kind of to some extent destroys your normals, and this is not a fluke. If you tessellate this and you put this this part into the, I don't know, into any rendering engine, you will have the same problem here. So when it's straight, just don't do squares. Now technically it is possible to do, but if it is 180 degrees or then just no luck. Just don't do that. But if it's shorter, so it will be like this, for example, or an arc or a curve, then it is a pretty legit way of doing stuff. Now this is not the A class technically, but it will do. Okay, so going back to my example, so I created this this square, and I'll do the same thing. I will delete the history, and then I will align it as a G2. I'm not sure about the extra rows, but we will see. So I will select it, and I will align it with this one, like this. Yeah, I definitely don't need extra CV rows. Or maybe I just don't need the linear. Yeah, maybe just not linear. Yeah, much better. Okay, now I'll probably remove explicit control. That's the same. Then I will remove the amount of degrees. So I prefer to have the same CV count on both of them. It's just easier to manipulate. But for the method itself, it's not that important. It just will be a little bit harder for you to control. All right. So once again, what happens? I took this surface, which I built using these two rails, so it has the proper direction, and I basically aligned this surface to this technical surface, like this. And once again, it built the way using the rails that it actually follows the desired direction based on this construction, so based on my limitations on this curve and this curve and this curve. So it's already, you can call it, kind of rotates in the proper direction. And this surface is aligned to this one. So this is the classical example of the cross align. Now, if I'll check it, it definitely will be curvature. I can move some CVs around and tweak it a little bit, of course. So first, let me open it up and see how it goes. Isolate this, and well, by the naked eye, it looks fine, but you know, we are professionals, so let us check it in a more professional way. Now, we have a lot of diagnostic shadings, which I use time to time. Now, your main instrument here, of course, is your zebra stripes. The clay ambient occlusion can be pretty useful if you're looking for some concave or convex discrepancies. And, you know, all of them actually to some extent can be useful, especially the curvature evaluations. It's actually quite useful too, but
Just to show you another options, I would like to show you another tool which I use quite often in my modeling process, is when I will use these. For me, it's here. For you, it's supposed to be, I believe, somewhere in the control panel. I believe this is it. It's called cross section editor. So you select it. Let me just quickly as the axis increment that will do. So I will use only Z, and let me just turn that on. It will be like maybe 5. The amount, let's say 20 will be enough, I believe. So let's say 7. Okay, like this. So what this cross section does, well, it's basically makes a cross sections from the specific direction and then creates the curvature combs on them, which basically gives me a pretty clear picture of what's happening across. Now, please note that some of you, and I know that, not maybe you specifically who's listening this, but I see this kind of strange behavior from the rookies who are coming into our studio time to time. So if you, let me just kind of clear it. So what people often do is they will go to the parameterization window, this one, on the control panel. Oh, sorry, not this one, the UV curvature, this one. And they click on these U and V displays to show the deviations. And then they look at that and like, oh shit, nothing is connected. What the hell is going on? How I can fix it? And then they will try to fix it looking at this stuff. I don't know why people do that. As you can see, there is U and V, which means this is a UV coordinates of the surfaces. And if I will rotate the surface, its UV coordinates will be rotated, and the curvature combs will be, well, first of all, different scale, and they will be in the different direction. So because these UV coordinates, it kind of creates over the isoparms, and they describe these UV parameterization, basically the clamped values from 0 to 1, and they are not the perfect way to check your surfaces. Only if they are coplanar or they are literally the same surfaces which you extend and then realign, then yeah, you can use this. But in all other aspects, it's kind of useless. So just don't use it. Use the cross-section or the diagnostic shading instead. So let me just kind of digress again. So it looks fine. Now I'm looking mostly at these. Actually, no, it's not that fine. I see some small discrepancies. So let me quickly tweak that. So do it like this. I will take my surface. Actually, for this technical surface, I can delete the history, and I can take this CV. This is the tangent line. Maybe even 100, and I will slightly move it down like this, and then this one. Now for you it's probably really difficult to see what the hell I'm doing. I'm just trying to make the connection smoother a little bit. Once again, as you see already, that the it's pretty easy for me because I can have the position, tangency, and curvature at my disposal. Even if it was a G-free connection, I have a G-free line as well. So pretty much as I need. And it basically works. Yeah, alright. It basically works like a charm in these situations. Alright, that's good enough. Let me clear this and go back to my surface, and let me quickly check that it is positional. It is positional. It is positional. Well, that's fine. Now I will delete the history here and just tweak some things manually. Now you can't really get away from, you know, manual adjustments. Sometimes you really need to do it just to slightly change the form when
you know, just bends in a it's a very tiny adjustments, but it's always good to have a little bit more of a natural flow. Now this one is just fine. This one is just fine too. Maybe yeah, okay, that's good. Okay, so this is what we have in as a result. Now let me show you what will happen if I will do the same stuff. Let me just delete the history. I will move it away somewhere here. We'll just remember that this is the surfaces we built using the cross-align. And I will do the same thing, but without the cross-align. Basically kind of the standard way, as you, I believe, understand really well already. So square number 1, the square number 2. So now I have a decision which one I will align to which. Now let me align. First of all, that was 4 degrees. Like that. Now suddenly I don't have any controls over here, because if I will align these to these, I definitely will, but then I lose the controls here. So basically all what I want to say is that now there is a lot of manual work. So let me just do it here. I will remove this to 4 degrees like that, and I will make myself pretty much really similar connection. But if now we just kind of turn on the groups here, you're gonna see that it's close but not exact. Look at all of this pinching, right? Okay, so I need to fix this. And the problem here is now, as this is the standard alignment, so this surface aligned to this one, maybe actually, you know what, it will be easier. No, it will be fine. That means that to change this, I need to change these row CVs of the original surface, which I will do. So I will pick these rows of CVs and slightly move them around. Let's work more before curvature. This one. These. All right, I believe in terms of the way how it behaves, this is good enough. So let me now clear this. And let me see what I'm gonna do with these surfaces here. Now I'll do the same stuff. Move this one with delete 100. Move this a little bit here. All right, let's call it a day. So we did somewhat the same thing. We take it didn't really take us a long time, because once again this is just the two surfaces stuck together, nothing really special. But if I look now at all of them, so I did my work here, and I'll aligned it. I used my cross sections and tried to work as good as I can. And now if you look at both of the surfaces, this one which I built using the cross align, and this one which I used built with just the standard align, and align this surface to this one and fix this part, you're gonna see the two results just from the front. And I don't know, do you really spot that or not, but this example, this one has a more natural transition here rather than this one. It bends too much here. There is, like, as you can see, like a small, like, flat plateau, which is kind of more prominent than here. This is the gradual transition. This is like more flattened here.
Same with this one. On top of that, if you look here, you're gonna see that I have this ask curve like this, and this doesn't, and this doesn't have it because this one has a linear interpolation for these curves, and they are matching these kind of the different height and different extrusion for these two surfaces, so it goes up and down like this, like S. These one, as I just forgot to do that, I need to do it manually. Now these one I just did automatically. So overall, these surfaces are similar. These one, even though that I spent less time on that a little bit than on this one, is a little bit cleaner. And what's more importantly, I don't need to fiddle with the cross sections and zebra stripes that much, because I know that this surface already has the proper direction. And in this situation, there is no other chances as to go in and work with it, because the deviation for the cross section was pretty big in comparison to here. This one I can just delete it and just not even bother with small adjustments and let it go. It will be almost identical. So that is the difference. Now in practice, when you create a lot of surfaces like that, let me actually do it one more time, just it will kind of settle with you. So one rail, then the curvatures, these, oops, sorry. So you create your rail. If you have an option to create a to snap to something, then do that. So this is your main step, right? Then you create your first surface, right? Realign that, and then you create the second one. So basically, these, and these, and realign that to your desired to the second part. Sorry, like this. Now this one definitely supposed to be 4 degrees, and this one's supposed to be 4 degrees, like this. And this is basically it. So as you can see, it's really easy to maintain, and if for some reason you want to change something, it's really difficult, easy as well. Now, for example, you want to redo it, you want to change that, you're going to change this one. And once again, everything will happen on the fly. So the way how you change this one affects both of the surfaces. Okay, oh, sorry, I deleted the original ones. Well, anyway, you get the point. Use the cross align. It's really practical, especially in the situations where you have not the two surfaces, but 3 or 4 or 5. When you create like the some kind of handles, for example, for like a knives or some kind of elongated shapes of swords or whatever, there will be a lot of parts like that. If you're creating something like a boat or whatever, then the chances it kind of split a lot of chunks which need to gradually flow one to another. You still use the cross align. And just in general, the cross align, if something goes wrong, you don't like the edge of a connection, you can always extend linearly, realign, take these technical surface and move the CVs to adjust both of the surfaces. Alright, that's it for me. Thank you very much, guys, and I will see you in the next one.